Hi everyone, in this lesson we're going to learn how to graph polynomial functions. And so on this first page I have some definitions for you to take a look at. First of all, a polynomial function is a function of degree n, and I have an example there. A sub n is always going to be our leading coefficient. N is the degree of the polynomial. And a sub 0 is what we call our constant term. Steps for graphing a polynomial function. Well, the first thing you're going to want to do is identify the end behavior of the graph. And you can use this table as a guide. So for example, if we were looking at the graph of y equals x cubed, in this case, we have an odd function, so the degree is odd. The value of a, which is, we have a visible 1 here, so 3 is n, and a is greater than 0. So we have this first situation. We have an odd degree, a is greater than 0, so on the left, the end behavior is falling, and on the right, the end behavior is rising. Another example would be if we have y equals x squared. Well, in that case, n is even, that's n, right? And we have a value of 1 in front, a is greater than 0. So that would be this situation. We're on the left part of the graph, we're rising, and on the right part of the graph, we're also rising. So those are just some examples, but we'll go through a bunch together so that you feel comfortable. The next step in graphing a polynomial would be to find the x-intercepts. We're going to do that by setting the polynomial equal to 0 and solving. So we set the whole thing equal to 0 and solve. We're going to find the y-intercepts by substituting 0 in for x. We're going to determine if there's any symmetry. Right? We can use the algebraic method to do that. We'll practice that together. What that means is we're going to substitute a negative x into the original function. If we end up back with the exact same function, it's even and reflects over the y-axis. If we put a negative x into the function and every term has a sign change, that would be odd, and that would mean it's going to reflect over the origin. It's just another guide to helping us do the graph. We're going to determine the number of maximum turning points. Right? So if f is a polynomial function of degree n, then there's going to be at most n minus 1 turning points on the graph. So going back to our example of y equals x cubed. So in this case, n is equal to 3. So we're going to have n minus 1, at most, n minus 1 turning points. So we would have 3 minus 1. So in the case of y equals x cubed, we're going to have at most 2 turning points. And of course, that graph looks like this. And we have a turning point here, and we have a turning point here. Turning point means that we're either going from increasing to decreasing, or decreasing to increasing. Step number 6, we're going to identify any relative maximum and minimums, and we can use the calculator to do that. That would be the calculate feature. You get to that by going to second trace, either number 3 for minimum or number 4 for maximum, and then we're going to sketch the graph. All right, so we have our first example here. And all we really need to know about this graph is that the value of the first term is x cubed. So let's write that down. We've got our 1x cubed. And since we have 1x cubed, we know that that value of 1 is a is greater than 0. The degree, n is equal to 3, so our degree is odd. And so we know that it's going to fall on the left and it's going to rise on the right. And let's just circle that in here. So it's odd where a is greater than 0. And we know that the parent function y equals x cubed just does this, and that makes sense with what we've included for number 1. Now the next step is number 2. Find the x-intercepts by setting the polynomial equal to 0 and solving. Well, this is a pretty long polynomial. There's 4 terms. It might be a little tricky to just solve algebraically. So what we're going to do is we're going to put this into our calculator, find one root, and then we can reduce it by using synthetic division. So we're going to open up our calculator and enter in the polynomial. So you're going to go to y equals, and you're going to enter in that polynomial, x cubed plus 6x squared minus x minus 30. Once you do that, you're going to go to zoom 6 for a standard window, and we're going to look at the polynomial. Now it looks like we have zeros at, let's see, -5, -3, and 2. So we're just going to confirm that using synthetic division. So I like the number 2. It's positive. It's easy to put in the box. I'm going to try synthetic division using that. All right, so we're going to put 2 in the box because we're pretty sure by looking at the graph that 2 is a root. 2 is a 0. Now we're going to use synthetic division to reduce our polynomial to make it easier to factor and solve. Okay, and 2 is definitely a root because we got 0 as a remainder. So what are we left with? We're left with 1x squared plus 8x plus 15 equals 0. And now we want to factor that. And that would be x plus 5 and x plus 3. So that would give us another 0 at -5 and even another one at -3. So all of our zeros, all of our solutions, our roots, our x-intercepts would be the values of 2, -5, and -3. Right, now the next step says find the y-intercept by substituting 0 in for x. So all we're going to do is replace x with 0 everywhere in our function. And when we do that, we get a value of -30. So that means that we have a coordinate at 0, -30. It's helpful when we sketch our graph. Now we want to find out if there's any symmetry. So we're going to substitute -x into our function and see if our terms change sign or not. You have to be really careful when you do this. Make sure you use parentheses and just take your time and write it all out. It really is worth it. Anytime you have a negative number raised to an odd power, it's going to stay negative. So we're going to get -x cubed here. For the next term, we have a -1 raised to the second power. That's going to become even. That's going to be plus 6x squared plus x minus 30. Now, if we compare that to our original function, so we want to see, did all the terms signs change or did none of them change? Well, if we look at, we started here, we had a positive, oh, the sign changed. Then we went here, the sign didn't change. Right away, we know this is neither, because either all of them change and it's odd, or none of them change and it's even. So in this case, we do not have symmetry. So we'll just make a note here, neither. Find the maximum number of turning points. Well, we know that n in this case is 3. Our degree is 3. So we want to know what is n minus 1. 3 minus 1 is 2. So we have, at most, 2 turning points. Okay, our minimum and our maximum. So we're going to use our graphing calculator to do this. First, we're going to find the minimum of the graph. All right, now you can't quite see the minimum because I'm using a standard window. I'm going to go to Window, and I'm going to make my Y minimum -50. I should really be able to see it if I do that. And I'm going to go back to Graph. Okay, great. Now I can see it. So now we're going to calculate the minimum. We're going to go to Second Trace. And remember, the buttons are being highlighted in red on my screen, so you know where to look for them. And I'm looking for the minimum, so I'm going to pick number 3. And I have to move my little spider a little left to of the minimum and hit enter. Move them a little right to the minimum and hit enter. And then when it says guess, we just hit enter again. And there we have our minimum value. So we're looking at 0.08, -30.04. Now let's take a look at the maximum value. We're going to go back to Calc. This time we're going to pick number 4 for maximum. We're going to move our little spider to the left of our maximum, to the right of our maximum, and hit enter. So you have to hit enter 3 times. You move them to the left, enter. Move them to the right, enter, and then enter again. And we get -4.08 and 6.04. Okay, wonderful. Now we have everything we need to sketch a beautiful graph. So it says sketch the graph using all the key points and information you identified above. Now this graph does not have to be to scale, so don't stress yourself out at all. So let's plot our x-intercepts. We're at 2, we're at -5, and we're at -3. So we know those are important numbers. Right? We also know that we have a y-intercept at 0, -30. All right, and we have a minimum at 0.08, -30, 0.04, so right about here. And we have a maximum at about -4.6, so right about there. And now we can go ahead and sketch the graph. We know that we fall on the left, rise on the right, and that is our guide for connecting our dots. All right, so we're done with that graph. Let's take a look at the next one. Sketch the graph of the function -x² + 9. Well, let's write out the first term here, -1x². We know that a is less than 0, and we know that n is equal to 2, which is even. So if we look at our chart, where is n even but less than 0? So we know that we're going to fall on the left and also fall on the right. The next thing is finding the x-intercepts by setting the polynomial equal to 0 and solving. Now in this case, we only have 2 terms in our polynomial, so I don't really feel the need to go ahead and try to look at the graph ahead. I'm just going to set this equal to 0 and solve it. All right, so we know we have x-intercepts at ±3. Same process again for finding the y-intercept. We're going to replace x with 0 everywhere in the polynomial. To find symmetry, we're going to substitute negative x into our function. Like I said, please be very neat and write it all out. The only time students make mistakes is when they think they are the person that does not have to write it out. And they would be wrong. Now, we end up with negative x squared plus 9, and of course, our original function was negative x squared plus 9. They match. If they match, if no signs have changed, that means that we are reflecting over the y-axis. This is even. Right? N is equal to 2 in this case. N minus 1 is going to be 2 minus 1. So that means we're going to have at most 1 turning point. So we have negative x squared plus 9. We already know this is a parabola. It's going like this. We're definitely not going to have a minimum. So we don't have to look for that in this case, but we do know that we do have a maximum. So let's take a look at that on our graphing calculator. We're going to go back to y equals. We're going to clear out our function. We're going to enter in our new function and make sure here you use the negative button that I have highlighted in red and not the minus button. You will get an error if you do that. So it's negative x squared plus 9. We're going to do zoom 6 for a standard window. Okay, there's our graph. We're going to do second calc, maximum, a little to the left, enter, a little to the right, enter. When it says guess, you literally just hit enter again. Now, we get this value of x of negative 1.463 e to the negative 6. That is scientific notation. That means that you are to move the decimal 6 places to the left. All right, so basically what we got for x is 0, and our value of y is 9. And now we get to do the fun part. We're going to sketch the graph using all the key points and information identified above. And of course, this does not have to be to scale, but this one is pretty easy to make to scale. So we're going to plot our x-intercepts first. We know that we have x-intercepts at 3 and negative 3. And we have a y-intercept at 9. Okay, our maximum is, of course, the same as our y-intercept. And we're going to go ahead and sketch our graph. And we can see that we've proven that we do have even symmetry, that we do reflect over the y-axis. We only have one turning point, and looks like we're good to go. Let's try number 3. For number 3, as usual, I would suggest you pause the video, try it yourself, and then rejoin when you're ready. Okay, the first term we have negative 1x cubed. A is less than 0. N is equal to 3, which is odd. So in the table, we're looking at odd, A is less than 0. So we're going to have rises and false. Right. The parent function, just to make a little note here, the parent function y equals x cubed looks like this. And if we were to change that by just putting a negative in front of it, it's going to look like this. All right, so, and that's what our table is demonstrating. So the table helps, but you should really remember what the parent functions are. and what happens when we reflect over the x-axis. All right, we're going to find the x-intercepts by setting the polynomial equal to 0 and solving, but this is a pretty long polynomial, so I'm going to look at it on my calculator, and I'm going to find a root, and then I'll reduce it using synthetic division. We're going to go to y equals. We're going to enter in our function. Make sure you use the negative button, not minus. We're going to do zoom 6 for a standard window. And it looks like we have 3 roots. I'm going to use the root of positive 1 to start reducing my polynomial. And then I'll just, prove that my other roots happen at, it looks like, plus or minus 5. You could pick any of those roots and reduce. I just think 1's just easy, so I'm going to go with that. So I think 1 is a root, so 1 goes in the box. We got a 0 as a remainder, so we know that 1 is indeed a root, a 0, an x-intercept, a solution. Now we can finish. So we have negative x squared plus 25 equals 0. We end up with x equals plus or minus 5. So we did prove that the x-intercepts occur at 1 and plus or minus 5. For the y-intercept, we're going to put 0 in for x. So we have a y-intercept at 0, negative 25. Now we're going to see if we should be expecting symmetry or not. So we're going to replace x with negative x. Now this can be a little tricky, so write it out and take your time. So if you compare to the original function, we change signs. We don't change signs. Okay, so we have neither. We are not expecting symmetry. How many turning points? Well, we know in this case n equals 3. We need to know what n minus 1 is. N minus 1 is 2. So we're expecting at most 2 turning points. Okay. Go back to our calculator for the minimum and the maximum. Now we can't really see them at all, so I'm going to go back to window. Let's see, I'm going to make my y minimum, I don't know, negative 60. I'll make my y maximum 60. I'll look at my graph, make sure I can see my minimum and my maximum. Okay, I didn't guess very well. I'm going to pick slightly lower y minimum. Should do it. There we go. Now I can see my minimum and my maximum. So I'm going to go to second trace, number 3. I'm going to move my little spider down a little bit. They're asking a little bit to the left, please. I say yes, enter, a little to the right, enter, guess, enter. I get negative 2.57 and negative 65.67. Now I'm going to go back to my calculator. I'm going to calculate the maximum, second trace, pick number 4, move my spider to the left of my maximum. Enter, to the right of it, enter. And I get 3.24, 32.49. Now we get to do the fun part. First, I'm going to graph all my intercepts. So my intercepts occur at 1, plus or minus 5. My y-intercept occurs at negative 25. This is not to scale. My minimum occurs at negative 2.5 and negative 65. Up there, something like that. My maximum occurs at a little past 3 and at a little past 32. And I had said that my graph rises and then falls. We looked at step 1 of doing this. Now we can draw on our graph. And that's it. So you guys will have a lot more time to practice these. Hope this lesson really helped. Good luck. Have a great day.